Hey, fifth graders. I'm sorry that I can't be with you guys today, but I still want to make sure that we're able to go over our study guide. Today you're with your substitute, and I want us to go through each of these different questions. I'm going to go through how we would solve them, and then I'm also going to talk about the answer that you should have gotten. You received this study guide yesterday, and I think Miss Adams may have passed it out, and you may have taken it home and already completed it. If you have completed it already, please still make sure that you're following along and check to make sure that you did your work correctly and that your answers are correct. Also, if you were not here yesterday, please let your substitute know so that she can get you a copy of the study guide so that you can follow along. Let's go ahead and get started. Number 1, Mrs. Adams' class is presenting a play. The chairs in the auditorium are arranged into 3 sections. 1, 2, and 3. The question asks us to write an expression that could be used to determine the number of chairs. I know an expression is like a number sentence, right? It's what we're going to use to solve the problem. So the first thing that I'm going to do is I'm going to look at how many chairs are in each section. And I know that I can solve this by using length times width, because area is length times width. To figure out the length and the width, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then I can count my width. 1, 2, 3, 4, 5, 6, 7. I know that it's going to be the same throughout. So this would be 14 and 7 and 14 and 7. Now, when I have a length and a width, I'm finding my area. My area is what is in the middle. I have 14 times 7, and this would be 14 times 7, and this area would also be 14 times 7. Well, now that we've figured out how to figure out one area, we know that we can do this 3 times. So my expression would be 14 times 7, which gives me one of the areas. And then I'm going to do that 3 times. So I'm going to multiply that by 3. Let's go to the next question. How can you write a numerical expression to represent the phrase using only numbers and symbols? Let's read the first one. The sum of 6 and 2, then divided by 26. I know that sum is adding, and divided means I need to use division. The sum is a fancy word, of 6 and 2 means that I'm going to put these in parentheses. 6 plus 2, because that's the sum. Then I'm going to divide this whole group by 26. Divided by 26. Let's take a look at the next one. The difference of 55 and 15 times 3. I know difference is subtraction of 55 and 15 times 3, and times would mean I need to multiply. So if I'm looking at the difference, I know that I need to use subtraction of 55 and 15. So 55 minus 15, and I'm going to multiply all of that times 3. Next, I'm going to read question number 3. Genesis bought a 510 square inch poster. The length of the poster is 34 inches. So I have my length of 34. I have my width, which I don't know. And I know that my area is 510 square inches. This is inches. Now I need to figure out what this width is. Well, if I have the area and I have the length, then I can find the width, because I know length times width equals area. So area divided by this 34 is going to give me my width. So 510 divided by 34. And I'm going to use partial product strategy to solve this. So to do this, I need to figure out the multiples of 34 that can fit inside of 510. 34 times 1 is 34. I know 34 times 2 is 68. I know 34 times 4 would just be 68 plus 68, which gives me 136. I know 34 times 10 is 340. And then I'm not going to go any bigger because if I start going up by tens, then I know that this will become too much. So this looks like a good place to start. I know 34 times 10 is 340, and that can fit inside of 510. 34 times 10 is 340. Then I subtract. 0 minus 0 is 0. 1 minus 4 can't do it. Got to borrow. This turns into 11 minus 4, which gives me 7, and 4 minus 3 is 1. So now I have 170. I need to try and subtract from 170. So 340 is too big. Can't use that one. The next multiple I have is 136. Well, I can use 136 because 34 times 4 is 136, and that can fit inside of 170. So 340 times 4, meet in the middle and put my answer, 136. Then I subtract. 0 minus 6 can't do it, need to borrow. 10 minus 6 is 4, 6 minus 3 is 3, and 1 minus 1, no worries. Next one, I know I can't use 136. 68 can't fit inside of there, but whoa, look at here. 34 and 34 are the same, and I can definitely fit that in there, and that'll bring me to my 0. 34 times 1 is 34. I subtract. 4 minus 4 is 0. 3 minus 3 is 0 as well. So I have 0. 10 plus 4 plus 1 are our partial products, and they're what are going to give us our answer. 10 plus 4 is 14, plus 1 is 15. So we know our width is 15. I'm just going to put it everywhere where it belongs. So how can I double check my answer? Well, I know that length times width is the area. So if I multiply 34 and 15 and get 510, then I know that 15 must have been that filling, that blank that we were missing. So I'm going to do the area model to multiply those two numbers. I'm going to break up 15 into 10 and 5. I'm going to break up 34 into 30 and 4. I'm going to multiply 10 times 30. I know 1 times 3 is 3, and then I have 2 zeros. 10 times 4 I know is 40. 5 times 3 is 15, and there's 1 0. So that's going to give me 150. And 5 times 4 is 20. Then I'm going to add them all up. 300 plus 150 plus 40 plus 20. 0 plus 0 plus 0 plus 0 gives me 0. 5 plus 4 is 9, plus 2 is 11. 1 plus 3 is 4, plus 1 is 5. That gives me 510. And 510 is our area, so that means 15 must be the correct answer. Taking a look at question number 4. This question has us doing two things. Solve using the standard algorithm. It's already set up for us. And then it needs us to check our answer using another strategy. Well, we know two really good strategies to solve multiplication. One of them being standard algorithm. So let's do that one first, since that's what it's asking us to do first. The first thing I'm going to do is I need to remember that I'm multiplying each of these bottom number, right, place values by each of these top number, my bigger number. So I'm going to do 3 times 8, then 3 times 7, then 3 times 5. Let's start with the 8. 3 times 8 is 24. put the 4 here, put the 2 here. 3 times 7 is 21, but then I need to add those 2 from earlier. So 3 times 7 is 21, plus 2 is 23. Used my 2, I put my 3 here and my 2 up here. 23, 3 times 7 plus 2. Now I need to do the next one. 3 times 5 is 15, plus 2 is 17, sorry. 3 plus 5 is 15, plus 2 is 17. I'm going to cross out that 2 because I've used it. All right, finished with the 3. Now I need to multiply this 2, also known as 20 because it's in the tens place, by each of the numbers above. 2 times 8 is 16. One thing we have to remember though is that we always put a 0 when we move into this tens place, right? Because we need to bring a 0 down here. Now we do 2 times 8 is 16. We put the 6 here, the 1 above the 7. 2 times 7 is 14, plus the 1 is 15. We put the 5 here, and the 1 above the 5. We've used that one, so we cross it out. Now I do 2 times 5, which gives me 10. I add 1, and that gives me 11. Great. Now that I've used both of these, I've multiplied them by each of these up here, and I've remembered to add that 0, right? And this 0 is very important for that second row. Now I can I can add. 4 plus 0 is 4, 3 plus 6 is 9, 7 plus 5 is 12. I add 1, 1 plus 1 plus 1 is 3, and then I have 1 there. My answer is 13,294. All right, so I have this answer, but it's also asking me to check using another strategy. So I am going to do the area model. I'm going to break up my 578 into 500, 70, and 8. I'm going to break up my 23 into 20 and 3. And I'm going to set it up just like this. I know this box I need to do 20 times 500. 2 times 5 is 10. I have 3 zeros. 1, 2, 3. 20 times 70. I know 2 times 7 is 14. And then I have 2 zeros. 20 times 8. 2 times 8 is 16. And 1 0. 3 times 500. 3 times 5 is 15. And 2 zeros. 3 times 70. 3 times 7 is 21. And 1 0. 3 times 8 is 24. Now I need to add up all of my partial products to see if I get that same answer. I'm going to start with my biggest. Make sure that I line up my place values along with the ones, right? 1,000, 500, check, check. 1,400, check. 210, check. 160, check. And 24, check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have all my numbers lined up. All my ones are in the same place. All my tens are in the same place. My hundreds, my thousands, and my 10,000s. Time to add. All these zeros plus 4 will give me 4. 1 plus 6 is 7. Plus 2 is 9. 5 plus 4 is 9. Plus 2 is 11. Plus 1 is 12. Carry my 1. 1 plus 1 plus 1 is 3. and 1 is 13,294. I got the same answer using both the area model and standard algorithm. So what is the product? 13,294. Question number 5. Mrs. Cohn solved 6,147 divided by 19 using the partial quotient strategy. She decided that the quotient is 503, remainder 10. What error did she make? Justify your answer. So to do this, I am going to try to follow what she did, but on my own chart. So I'm going to create 19, 6,147, and I'm going to start solving. So the first thing she did was 100. Let's do that. 100, 19 times 100 is 1,900. When I subtract, I get 7 minus 0, which is 7. 4 minus 0, which is 4. 1 minus 9 can't do it. This is going to turn into a 5. 11 minus 9 is 2. 5 minus 1 is 4. Okay, so she did this right. This is right. What about this one? So now I can kind of take a look here. She did 100 here. I know 19 times 100 is 1,900. 7 minus 0 is 7. 4 minus 0 is 4. 2 minus 9 can't do it, so she would have had to borrow here, which this would have turned into 3. 12 minus 9 is 3, okay? And 3 minus 1 is 2. So she did that part right too. Okay, she looks like she used another 100. She did 19 times 100, which gave her 1,900. Good. And then she subtracted. 7 minus 0 is 7. 4 minus 0 is 4. 3 minus 9 can't do it. She had to borrow. 13 minus 9 is 4. Okay, so she got that right too. I'm starting to see a problem right about here. 200 times 19, I know, is not 380. What times 19 would be 380? Well, that would be 20. If we did 19 times 20, that would give us 380. So let's take a look. 7 minus 0 is 7. 4 minus 8 can't do it. Gotta borrow. Okay, 14 minus 8 is 6. Good. So that part's right if she had made this 20. And then she did 3, which gave her 57. That's right. 19 times 3 is 57. So then we subtract and she got 10. So her remainder is right. What's wrong is that she added an extra 0 here, probably by accident. So in order to change this, we need to add these up properly. 300, so 100 plus 100 plus 100 is 300, 320, 323. So her answer should have actually been 323, remainder 10. Down here, I'm going to explain Mrs. Cohn added a 0 to 20, making it 200. When corrected, the answer is 323, remainder 10. All right, here's the next one. 330 divided by 15, that's what I see immediately. Using strategies based on place value or models, solve the problem shown. So I'm not going to use my partial quotients and my partial products because I know that they're asking me to use place value or models. So to do that, I'm going to create models. So I know that I'm trying to divide 330 up into 15 little pieces. So I'm going to make 15 circles. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 3 times 5 is 15. So there's 15 there. 310. To put that in model form, I could do 1, 2, 3, and 3 ones. Now, my only issue here is that I don't have enough hundreds to put evenly in 15 places. So I need to turn these and each of these into 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these, right? This will have 10 of those and this will have 10 tens. Okay, so let's start with the first one. Let's put those in to all of our spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. I need to do 10 tens of this. 1, 2, 3, 4, 5. Notice how I continued over here to make them even. 6, 7, 8, 9, 10. Done with that one. Let's take a look at this one. 1, oh, nope, can't start there. Got to start here because we ended right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done with that one. Well, now I have 3 tens left over. I need to turn these into 10 ones because I don't have enough tens to spread across evenly. I already have even twos all the way, even 20s all the way across. So I need to make these into ones. So I have 10 ones here, 10 ones here, and 10 ones here. So let's start with the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. Next one. 1, oh, can't do that. Gotta start here. 1, 2, 3, 4, 5. Now 6, 7, 8, 9, 10. Want to make sure we know that these are not here. Okay, so we got that one done. And now we have 10 more. Remember, we start where we left off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we've gotten rid of all these. And it looks like I have an even number in each one. So my answer of 330 divided by 15 would be 10 plus 10 plus 2, which gives me 22. There's 22 in each one. So 22 is my answer. All right, time for us to evaluate an expression. We have lots of fun with these ones. The first thing I'm going to do before I even start evaluating is I'm going to write gems off to the side so that I remember which order I need to go in. I know that my G represents grouping. My E is exponents. M is multiplying or dividing. And that's from left to right. And then this is subtracting or adding from left to right. So I go in this order. Looking at this problem, if I'm starting with grouping, I know that I need to start inside my group, right? So I'm going to start with my parentheses. 36 minus 27 is where I'll begin. So 36 minus 27. 36 minus 27. 6 minus 7 can't do it. 16 minus 7 is 9. And 2 minus 2 is 0. So this comes out to be 9. Now I have my new expression. When I see a parenthesis next to a number, I know that means I need to multiply. So this actually means 8 times 9. What is 8 times 9? Oh, I showed you guys this trick before with our fingers that we can do. But if you know your multiplication, you know that this is 72. Okay, now I have 4 plus 72 divided by 9. We've done all of our groupings. We have no exponents. Our next step is to do multiplying or dividing, right? So we're not going to start here because we need to divide first. 72 divided by 9 is 8. And then we are going to bring that down. We're done with multiplying and dividing. Now we can subtract or add from left to right. And we have 4 plus 8, which gives us 12. So our answer is 12. All right, let's take a look at this next question. Number 8. Hershey can pack 32 ice cream bars per box for shipping. If they need to ship 1,306, and you may have noticed that it said boxes and really had a hard time with this problem because this was actually supposed to say bars. If they need to ship 1,306 bars to Winholt Elementary School, which expression would be used to show the amount of boxes Hershey will need to ship all 1,306 bars? Well, I have some important numbers here that I need to remember. I know that Hershey can pack 32 ice cream bars per box for shipping. I know that they need to ship this many bars to Winholt Elementary. If we need to figure out how many boxes they need, we're going to need to divide, right? We need to figure out how many boxes can hold this. In order to figure that out, we would need to divide 1,306 divided by 32, right? Because 32 Hershey's bars, 32 Hershey's bars can fit per box. So we have 1,306. We divide them into 32, which would divide into each of them. And so our answer is C. Let's take a look at this next problem. Number 9. Mr. Cornell worked all night on a math problem. He thinks that 4 plus 3 times 5 equals 35. Why is Mr. Cornell incorrect? Use order of operations. We know what this is, to solve the problem correctly. Then explain your thinking. When I see that word order of operations, I already know that I need to write my gems. I know this is grouping, exponents, multiplication from left to right, and subtracting and adding from left to right. Let's see what Mr. Cornell did. Well, we know that the correct way to do this would be, let's do us first actually. This is how we would solve it. We know that we don't have any groups, so we don't have to worry about that. We have no exponents, don't have to worry about that. So our next step is multiplication or division. We could do 3 times 5, which would give us 15. And then We would bring down that 4 and add it, and we get 19. So what do we notice here? Mr. Cornell did not get 19, meaning that he must be incorrect. Let's see how he must have solved it. I'm thinking that he must have done it differently. Maybe he started with the 4. 4 plus 3 is 7 times 4 is 30. Is 35? Well, we figured out what I did wrong here. This is supposed to be a 5. Here we go. 4 plus 3 is 7 times 5 is 35. What did he do wrong here? Well, we can see that he started with adding, right? And do we start with adding when we use GEMS? G-E-M-S. Multiplication comes before subtracting and adding. And we see that there was a multiplication problem within this expression. So we needed to start with that first. So let's explain our thinking. Mr. Cornell did not use order of operations. He added before multiplying. All right, we are almost done. Just a couple more questions. Number 10, Sonic and Knuckles collect rings. Sonic stores his in a 17-row vault with 30 rings in each row. Knuckles has twice as many rings as Sonic. What is an equation to represent the total number of rings Knuckles has? Well, I know that rows go this way, right? And if there are, he has 17 rows. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that there would be 17 rows. We also know that he would have 30 rings in each row. 30. Knuckles has twice as many rings. So this, a second time, would be how many Knuckles has. So what would be an equation? This brings me back to that first problem that we talked about. Sorry, right here, right? We had length and width. The same thing here is length and width. So if we want to figure out how many Sonic has, Sonic has 30 times 17, which means that if we need to do twice as many as that, we need to do 30 times 17, and we need to multiply that 2 times. Now we need to solve though. How many rings does Knuckles have? Well, we know that when we use GEMS, we do groupings first. Our first grouping is 30 times 17. And to solve this, I could use my area model, 30, and there would be 0 there. So we don't even need to use that box. And then 10 and 7. I know 1 times 3 is 3, plus 2 zeros is 300. I know 7 times 3 is 21, plus 1 0 is 210. If I add 300 plus 210, I get 510. So I have 510 here, but I need to multiply that by 2. If I multiply 510 times 2, I'm going to get my answer to figure out how many Knuckles has, because Knuckles has 2 times as many as Sonic. So Sonic has 510, right? We know this, but he has too much. Knuckles does. So 510 plus 510, 0 plus 0, 0, 1 plus 1 is 2, 5 plus 5 is 10. How many rings does Knuckles have? 1,020. All right, here is our last question. It's kind of broken down into a few parts. Enrique solved 48 times 37 using standard algorithm. He determined that the product of 48 times 37 equaled 480. You can see his work here. Did Enrique solve the problem correctly? Yes or no? Well, why don't you and I solve the problem and see what he did wrong? The first thing I need to do is 48 times 37. I'm going to write my problem out. I know that when I multiply each of the bottom values by each of the top ones. So I'm going to multiply 7 times 8 and 4. And I'm going to multiply 3 times, or 30 times 8 and 4. 7 times 8, I know is 56. I'm going to put a 6 here and a 5 up here. I know 7 times 4. I know 7 times 2 is 14. 14 plus 14 is 28, right? 7 times 4 is 28. Plus 5 is 33. Cross out that 5 and done. So now I'm also done with that 7. Now I need to move on to the 3. I know that I need to put a 0 here because this represents 30, right? When I do 3 times 8, I know that 8 times 2 is 16. So 3 times 8 would be 24. Sorry, I had to figure that one out in my head. So I will put a 4 here and a 2 here. Now I need to do 3 times 4, which is 12, plus 2 would give me 14. Now I need to solve. I add 6 plus 4, 0 is 6. 3 plus 4 is 7. 3 plus 4 is 7. And bring the 1 down. Let's take a look at what this person did. First of all, did they get the answer wrong? No, they did not solve it correctly, right? Did Enrique solve the problem correctly? No, because they got 480. We got 1,776. Okay, let's explain. What did he get wrong? He answered 480 when the answer, the correct answer is 1,776. That's what happened wrong, right? And if you think he solved it incorrectly, which we do, what should he do differently? Let's take a look. He has this right, this right, this right. Oh, I noticed something wrong here. What did he forget to put over here? He forgot to put a 0. He would need to line these up correctly, and that would help him figure out the right answer. Enrique needs to put a 0 placeholder in the tens place. Now, I showed my work up here, but it did give us some space to show it down here too. Alrighty. So that is our study guide. We will be having our test tomorrow. Please make sure that you understand all of what's on this study guide. I would like for you guys to turn this in, though if you would like to take it home tonight to go through and practice and make sure that you understand each of these components, that may be a good idea as well. I expect you to turn this study guide in tomorrow, completely finished. And that's all. I hope you guys have a great rest of your day.